Hello students and welcome to Unit 6 Part 2 called Bivariate Data and Linear Functions. In this unit we're going to learn what bivariate data is and how it can be displayed on scatter plots. So our essential questions are: what are scatter plots? What do they display? How are they constructed? And what are correlations and what do they tell us about a relationship? So to start, let's define what this unit is all about: bivariate data. Bivariate data is numeric results from two sets of variables. Think about the prefix bi. Bi means two, variate in terms of variables, so we have two sets of variables. This is nothing new to you because we have been talking about independent and dependent variables, and those are two sets of variables. So here are two examples of bivariate data: a person's height and weight. There are two different measurements that are part of this statement. So that's two sets of variables, and they're both numeric because height and weight are both described by numbers. A second example is the time spent studying and the score on a quiz. We can see that there's two sets of variables because there is the time spent studying and then there's the score on the quiz. It's numeric because both of these are expressed in numbers. Bivariate data can then be displayed on scatter plots. This is an example of a scatter plot. Notice it is part of a coordinate plane, and it can be an entire coordinate plane. It's just in this situation, hours of study can only be positive values and scores on a test can only be positive values. That's why you see only quadrant 1. A scatter plot is defined as a graph used to display two sets of numeric data, in other words bivariate data, so that relationships between the two sets can be described in general on the coordinate plane. Noteworthy is the fact that these are distinct points on the graph. They are not connected because each dot represents one person or one situation or one link between the two variables, depending on what type of questions are being asked. Since this is hours of study and a score on a test called the Regent score, we can assume that one of these dots represents one person, how much they studied, and the score that they got. The relationship that you can see on a coordinate plane between the two variables, which are usually one independent, which you'll find on the x-axis, and one dependent, which we'll find on the y-axis, is called a correlation. And we'll talk more about what a correlation is. But for now, just know that the relationship is going to be some type of correlation. These scatter plots are useful because they can show at a quick glance if a relationship exists. In other words, you can quickly look at it and see what type of correlation there is between the two variables. In already what we've talked about, we've answered 3 essential questions. We've talked about what scatter plots are and what they display. A type of graph used to display two sets of numeric data on a coordinate plane. So in other words, our one essential question was, what are scatter plots? Well, a scatter plot is a type of graph. And what does it display, which was our second essential question? It displays two sets of numeric data, in other words, bivariate data. So we have talked about what they display. They display two sets of numeric data that might be related to each other. In other words, there may be a link between the two sets. And that leads us to what they can tell us. Scatter plots can tell us if a relationship exists between two variables. A correlation is used to describe that relationship. So let's move into how to make a scatter plot, and then we will look at how do we find this correlation. So the first step in making a scatter plot is to gather your data or use data previously gathered. So for example, you could actually go out and get your own data that would be gathering data, but you're going to be using, for the most part, data that has already been gathered. So for example, here in this input-output table, we have the relationship between the cookies in the jar and the time since they were baked. So we're going to use previously gathered data. The second step is to organize the data in an input-output table. So for example, if you were given a list of ordered pairs, you would want to organize them in an input-output table. Third, determine the independent and dependent variables, the x and the y. Well, in this case, the time since baked is the independent variable because the number of cookies in the jar depends on how long they've been sitting there. And then our last step is to graph the ordered pairs on the coordinate plane. So, for example, if the time since baked is our x and the cookies are the y, then this is the point 1, 24. So go over 1, always being careful to look at how the graph is organized. This is organized by halves. So here's 1 and up 24. 2, 16, so over 2, up 16. So it'd be like maybe right there. Because this line would be 15 since we're counting by threes. 3, 10, so over 3, up 10, so this would be 9, just a little bit more. And then 4, 7, so over 4, up 7. Now, you can see this is not perfectly linear. This is not a linear function, but you can see a trend. As the days go on, there are less cookies in the jar. That is what we refer to as a correlation. So once your graph is created, there are 3 types of relationships that could be evident that you could see. The first is called no correlation. This would be if there is no significant relationship between the 2 variables. A positive correlation is as one variable increases, so does the other. Now, this can be a strong or a weak positive correlation, but in essence, there is a relationship that exists. When the one goes up, the other goes up as well. And the last is called a negative correlation, which is the opposite of a positive. As the one variable increases, the other decreases, and it can also be strong or weak. Now we're going to look at each of these a little bit more in depth. Let's start with no correlation. This is an example of a graph with no correlation. You can see that the dots are very spread out. There's no pattern in the way they go. They don't go up, all go upward or all go downward. They're just kind of spread sporadically across the graph. This is called no correlation. And if there's no correlation, there's no significant trend. You don't see them all going up or all going down. They're kind of intermingled all over the graph. The conclusion is that there's no relationship. If this were number of minutes spent in school, the money your family made last week, there is no relationship between the 2 of those if this were the graph. A positive correlation is as one increases, the other increases as well. It looks like a positive slope. It looks like the dots are going upward. And the conclusion is that a relationship exists. These 2 are positively linked together. So for example, the more you study, the more your test score will be. The more you practice, the better you'll get. They both go up together. Now, like I said earlier, there can be strong and there can be weak positive correlations. If you look at this example, if I drew a line down the center of all the points, which we'll learn in our next lesson that this is called a line of regression, you can see that all the dots are very close to the line. Whereas here, if you draw a line through the center of the dots, they do tend to go upward, but they're much more spread out from that line of regression. So this would be called a strong positive correlation. This would be called a weak positive correlation. This would represent a strong tie between the two variables, whereas this would say they are linked, but not perfectly. Now let's talk about a negative correlation. It is a negative correlation if, as one variable increases, the other one decreases. When you look at the graph, it will look like a negative slope. It'll look like it's moving downward. The conclusion is there is a relationship between these two variables, whatever they are. Like positive correlation, there can be strong and there can be weak negative correlations. If I draw a line of regression on this graph, down the center of the dots, you can see that they're spread out from that line. Whereas if I draw a line of regression on this graph, they are much closer to the line. We would describe this as a weak negative correlation and this as a strong negative correlation. Now, let's move forward and talk about what different types of correlations can tell us about a relationship. So, for example, the scatter plot below shows the number of cookies in a jar from the time since they were baked. This is the same graph we made earlier. If we look, we can see that the dots are moving downward. We would call this a negative correlation. This negative correlation can tell us about the relationship. So remember, a negative correlation, as one variable goes up, the other one goes down. In other words, as the days go up, the number of cookies in the jar decreases. Write that in a statement. As time passes, that would be going upward, increasing. Okay? That's just this little side note. As time passes, the number of cookies in the jar decreases. So as one goes up, the other goes down. Let's look at another example. The scatter plot below shows the number of beach visitors in comparison with the average daily temperature of 11 days. If you draw a line through the middle of the dots, you can see that it's going upward. That means that this is a positive correlation. Now remember, as a positive correlation, as one variable increases, so does the other. So how does the temperature relate to the visitors? As the temperature outside increases, that's upward, more people, that's upward as well, go to the beach. So as one goes up, so does the other.